Hello everyone, how are you doing? I hope you're doing great. Uh, in this video, I will provide you with a brief answer to a worksheet on policy analysis workshop, and I hope you all have obtained the file from your group Telegram. To start with, question number one is related to factors determining real income. And in this example, simple linear regression model is used to estimate a linear regression model or a multiple linear regression model using data collected from 55,087 individuals. Here is the dependent variable. Here is the dependent variable. The dependent variable is real income, and we have age squared, sex, marital status, college graduate, and happiness status of the respondents. Using this information, the researcher has produced this regression output. Here is our result. And the model diagnostic tests are also presented. And here is the model diagnostic test result. And having this in mind, we are asked to judge the goodness fit of the model. Does the model fit the data very well? If your answer is yes, why? If not, why not? As you may recall from our previous lessons, we said that model goodness of fit is judged by F test. Here is the F test statistic. Where is it? And the corresponding p-value of F is given here. It is 0.000, which is less than 0.05. Normally, the F statistic or F test is used to test whether R square of the model. Here, R square is 0.180, which is 80%. F test is used to test whether this calculated R square is statistically significant or not. Bear in mind, the null hypothesis states that the model doesn't fit, which implies that the calculated R square is not statistically different from 0, or it is statistically insignificant. However, our evidence, p-value of F, is statistically significant, which implies that the model fits the data very well, or R square is statistically significant. And now you have a solid evidence to interpret the value of R squared. This means that about 80% of the total variation in real income is explained by the explanatory variables included in the model, while the remaining 72% is attributed to the disturbance term. When we come to question number B, where is it? Comment on assumptions of the ordinary least squares. What does it mean? Is there any violations of assumptions of the classical linear regression model? For example, is there a problem of heteroscedasticity? Is there a problem of multicollinearity? Let's get back to the model diagnostics test. Here, this is Brusque-Pagan or Cook-Weisberg test for heteroscedasticity, which enables us to test whether the error term is homoscedastic or not. And in order to do so, we have the calculated chi-square and its corresponding probability value or p-value. But in order to make a decision, you need to know what the null hypothesis does say. For example, let me regress current salary on education, beginning salary, job time, and previous experience, and let me conduct heteroscedasticity test, head test. And as you can see from here, the null hypothesis states that the null hypothesis states that the variance or the disturbance term is heteroscedastic. Look, H naught states that the disturbance term is homoscedastic. Homoscedastic means it has a constant variance. It has a constant variance. Here, the p-value is less than 0.05. Therefore, we reject this null hypothesis, which implies that the disturbance term is heteroscedastic. What's the solution then? What's the solution then? To run robust regression analysis. Robust regression analysis. Look, regress with real income. Look, real income, age. Let's do this. C.age double hashtag C.age, then female, race, marital status as another variable, that we have in the regression model. Marital status, okay, sex, college graduate, and high school graduate. Let me add the two variables left. High school graduate and the college graduate, and then comma as an option, you include robust here, and this gives you a robust regression analysis. Look, we have robust standard error here, and therefore when you come across a heteroscedasticity problem, you can run a robust regression. So our model has heteroscedasticity problem. Again, it has OV test. Look, OV test enables you to conduct Ramsey reset test for omitted variables bias. Therefore, we have a null hypothesis which states that the model has no omitted variables, but the F statistic and its corresponding p-value informs us to reject this null hypothesis. It has no omitted variables, it says, but we have a solid evidence to reject this null hypothesis. The conclusion is the model has omitted variable bias. Another diagnostic test is multicollinearity problem, and we said that if the variance inflation factor is greater than 10, the model has a multicollinearity problem. Here, since age squared is generated from age, this is normally expected, even though it is not this much serious. Other variables are okay, but age and age square creates a problem of multicollinearity. Another assumption of classical linear regression model is normality of the disturbance term, and we applied Shapiro-Wilk W test for normality, and here is the test, and here is the result. Here is the p-value, and this is W statistic, V statistic, and Z statistic. Since the p-value is less than 0.05, we reject the null hypothesis in this case. So we are done with comments on assumptions of the linear regression, classical linear regression models, or the ordinary least squares model. And as the third question under question number, question C under question number 1 asks us to conduct a significance test on each variables of coefficient in the model and interpret the statistically significant ones. And in order to do so, we must go back to the result and judge whether the variables are statistically significant or not. As you are seeing from the result, except white, look, except white, all variables are statistically significant. And we can now interpret the coefficient of each variable in the model. For example, as age increases by 1 year, real income of the individual increases by $1,720.9 on average, keeping the remaining variables constant. And when you come to age squared, it is statistically significant, and its sign is negative, which states that age squared and real income are inversely related, meaning when age squared increases by 1 year, a real income of the individual decreases by $16.557 on average, keeping other things constant. From this, we understand that age and real income are not linearly related, rather it follows inverted U-shape. What does that mean? At the early stage of, age of the individual, as age increases till a certain age threshold is achieved, income of the individual increases. But it turns out to be negative beyond the threshold specified. And when we come to age, sex is statistically significant. Our reference group is female here. Therefore, this coefficient refers to male respondents. And this implies that the real income of male is higher by $12,277.032 on average when you compare it with the income earned by female. ምን ማለት ነው? የወንዶች ከሴቶች ጋር ኮምፔር ስናደርግ ኦን አቨሬጅ የ12277.032 ብልጫ አለው ማለት ነው። ሶ ምንድነው ወንዶች ከሴቶች የተሻለ ያገኛሉ ነው። ሶስተኛ ሬስ ነው። እዚህ ጋም ሪፈረንስ ግሩፓችን አዘር ነው። ሬስ ዋይት ብላክ እና አዘር ብለን ነው የከፋፈል ነው። እዚህ ጋር አዘር ሪፈረንስ ነው። ስለዚህ እሱ ሪፈረንስ ሪግሬሽን አናሊሲስ ውስጥ የለም ማለት ነው። ለምሳሌ ይሄ ኮኤፊሽንት የዋይት ነው፣ ይሄ ኮኤፊሽንት ደግሞ የብላክ ነው። የዋይትን ከአዘር ጋር ኮምፔር ስናደርግ ኦን አቨሬጅ የኢንካም ሪል ኢንካም ልዩነት የላቸውም because it is statistically insignificant እዚህ ጋር እንደምታዩት ማለት ነው። but when you compare black with other, income earned by black is lower by $2,113.5 on average. On average, black ወይ ደግሞ ጥቁሮች ከሌሎቹ በታች ነው የሚያገኙት ነው። Another one is college graduate. ከኮሌጅ ግራጁዌት ያደረጉና ከኮሌጅ ግራጁዌት ያላደረጉትን ነው ኮምፔር እያደረግን ያለ ነው እዚህ ጋር the reference group is individual with no college graduate therefore ይሄ ኮኤፊሽንት የኮሌጅ ግራጁዌት ነው ማለት ነው የነን ኮሌጅ ግራጁዌት ኮኤፊሽንቱ 0 ነው ዜሮን ከዚህኛ ጋር እናወዳድራለን መጀመሪያ ግን statistically significant መሆኑን ማየት አለባችሁ here is the p value is less than 0.05 therefore this coefficient is statistically significant what does that mean the income earned by individual who is college graduate is higher by $13,730.272 on average when we compare it with what individuals who is not college graduate ስለዚህ የትምህርት ደረጃ ኢርኒንግ ላይ ማተር ያደርጋል ኮሌጅ ግራጁዌት ያደረጉ ኢንካማቸው ሃይ ነው ይበልጣል ከሌሎቹ ነው እዚህ ጋር ደግሞ ሃይ ስኩል ግራጁዌት ያደረጉና ያላደረጉት ይላል the reference is again individual who doesn't have college degree no high school degree ስለዚህ this coefficient is what attributed to high school graduate while that of no high school graduate is 0 0 ከ6500 ነው ኮምፔር የምታደርጉት ነው it is statistically significant therefore individual who is a high school graduate earns higher income than the one who doesn't have high school graduate more specifically በስንት ይበልጣል በ6500 ይበልጣል ማለት ነው ሌላው variable marital status ነው the reference group is individual who married እሱን ከሌሎቹ ጋር ኮምፔር እናደርጋለን እነኚህ ኮኤፊሽንቶች ይሄ ኮኤፊሽንት የዊዶድ ነው ይሄ ኮኤፊሽንት የዳይቮርስድ ይሄ ኮኤፊሽንት የሴፓሬትድ ይሄ ኮኤፊሽንት never married እንደምታዩት ሁሉም ከሜሪድ ካገቡት ሰዎች በታች ነው የሚያገኙት ነው more specifically widowed ከሜሪድ ጋር ኮምፔር ስናደርግ በምን ያክል ያንሳል በ2671 ያንሳል ዳይቮርስ ያደረገ ደግሞ ከሜሪድ ጋር ኮምፔር ስናደርግ በ1542 ያንሳል separated በ1887 ያንሳል never married በ3882 on average ያንሳል ማለት ነው therefore widowed individual earns $2,671 lower than married individual on average. Divorced individual earns $1,542.7 lower than married individual. እያላችሁ ኢንተርፕሬት አደረጉታላችሁ ማለት ነው ይሄ ኮንስታንት ነው ምንም የተለየ እንትን የለውም እዚህ ላይ so we don't worry to interpret it ይሄ ሞዴሉ እንትን ነው ያው ቅድም ኢንተርፕሬት አድርገናል ሞዴሉ ዲያግኖስቲክ እንትኖች ቴስት አድርገናል የመልቲኮሎናሪቲ ችግር የሄትሮስኪዳሲቲ ችግር የኦሚትድ ቫሪያብል ባያስ ችግርና ሌሎች እንትኖች አሉበት ማለት ነው ይሄንን በዚህ መልኩ ኢንተርፕሬት አደረግን ሁለተኛው ጥያቄ ምንድነው የሚለው አንደኛውን ጥያቄ እንዳለ ወስደን the only thing dependent variable በሌቨል የነበረው it was transformed into natural logarithm now instead of real income, now we have natural logarithm of real income. እዚህ ጋር የተቀየረበት እንደዚህ የሆነበት ምክንያት ምንድነው? ኢንተርፕሬቴሽን እንድትማሩ ነው እንጂ ምንም የተለየ ነገር የለውም። ምክንያቱም ኮኤፊሽንት ኢንተርፕሬት ስናደርግ እየተጠቀምን ያለነውን functional form ማወቅ ስላለብን for example if both dependent and independent variable is in level ለምሳሌ y እና x ኢንተርፕሬት የሚደረገው ምንድነው? x በአንድ ዩኒት ሲቀየር ቼንጅ ሲያደርግ y በቤታ 1 ቼንጅ ያደርጋል። ሌቨል ሎግ ሲሆን ደግሞ ኢንዲፔንደንት ቫሪያብል ሎጋሪዝም፣ ይሄ ደግሞ ሌቨል ሲሆን ኢንዲፔንደንት ኮኤፊሽንቱን በመቶ አካፍለን ፐርሰንት እናደርገዋለን። ይሄ ቼንጅ ይሆናል። ስለዚህ change in y is equal to beta over 100 multiplied by percent times change in x ይሆናል። log level ማለት ደግሞ dependent variable logarithm independent variable level ሲሆን logarithm ያለበት always percentage change ነው የሚያሳየው። እዚህ ጋር ግን ያ percentage change ስለሌለ እዚህ ጋር ምንድነው የምናደርገው? ኮኤፊሽንቱን በመቶ እናባዛለን then multiplied by change in x ይሆናል። log ሲሆን a percent change in x leads to beta percent change in y ነው የሚሆነው። ስለዚህ ይሄ በደንብ መያዝ አለበት ማለት ነው። so the dependent variable is in logarithmic form. dependent variable logarithm ነው። ስለዚህ እያንዳንዱን ኮኤፊሽንት በመቶ ታባዛላችሁ ማለት ነው። በመቶ ታባዛላችሁ። ለምሳሌ ይሄንን በመቶ ስታባዙ ስንት ነው የሚሆነው ማለት ነው? ይሄ በመቶ ሲባዛ 13.1 ነው የሚመጣው። 13.1 What does this mean? As age increases by 1 year, the individual's income increases by 13.1% on average, keeping other things constant. እዚህ ጋር ደግሞ ይሄንን በመቶ ሲታባዙ minus 0.1 ነው የሚመጣው። በመቶ ሲታባዙ What does that mean? As age squared increases by 1 year, the individual's income decreases by 0.1%, keeping other things constant. And here that is going to be 63.4. And when we interpret this, ወንዶች የሚያገኙት ኢንካም ከሴቶች ይበልጣል። በምን ያክል ፐርሰንት ይበልጣል ከተባለ በ63.4% ይበልጣል። እዚህ ጋር ቅድም እንዳልነው ቅድም ዋይት ነበረ ኢንሲግኒፊካንት የነበረው፣ አሁን ደግሞ ብላክ ኢንሲግኒፊካንት መጥቷል። ብላክ እና አዘር መካከል የኢንካም የኤርኒንግ ዲፈረንስ የለም ለማለት ነው። ግን ምን አለ ዋይትን ከብላክ ጋር ኮምፔር ስናደርግ የዋይት ይበልጣል። ቢኮዝ ፖዚቲቭ ስለሆነ በምን አክል ከተባለ በ8.7% ይበልጣል ነው። አዘር እና ብላክን ኮምፔር ስናደርግ ግን ልዩነት የላቸውም። ሌላው ኮሌጅ ግራጁዌት እና ሃይ ስኩል ግራጁዌት ነው። ቅድም እንዳልነው እዚህ ጋር ነን ኮሌጅ ግራጁዌት ሪፈረንስ ነው፣ እዚህ ጋር ደግሞ ኖ ሃይ ስኩል ግራጁዌት ሪፈረንስ ነው። ስለዚህ የኮኤፊሽንት የቫሪያብሎቹ ነው፣ እዚህ ካታጎሪ ነው። ሁለቱም ስታቲስቲካሊ ሲግኒፊካንት። ለምሳሌ ኮሌጅ ግራጁዌት ያደረገውን እና ያላደረገውን ሪስፖንደንት ኮምፔር ስናደርግ ኮሌጅ ግራጁዌት ያደረገው የሚያገኘው ኢንካም ይበልጣል። በስንት? በ48.1%። ይሄኛው ደግሞ በ43.3% ይበልጣል። ሶ ኢንካም ኦር ሪል ኢንካም ኦፍ ኮሌጅ ግራጁዌት ኢዝ ሃየር ባይ 48.1% when we compare it with individual who has no college graduate. Individual who has high school graduate earns 43.3% higher income when we compare it with income of individual who doesn't have high school graduate. This is marital status. ከማሪታል ስታተስ ጋር ተያይዞ ደግሞ እዚህ ጋር ዊዶውድ ስታቲስቲካሊ ኢንሲግኒፊካንት መጣ፣ ዳይቮርስድ እንደዛው። ሶ ያገቡትን ከሴፓሬትድ እና ከኔቨር ሜሪድ ነው ኮምፔር የምናደርገው። ያ ማለት ምን ማለት ነው? ሴፓሬትድ earns 13.6% lower income when compared it with married, and never married earned less income, which is lower by 15.4% when we compare it with married individuals. This is the interpretation, and I hope we are done with question number 2. Yes, the model fits the data very well because R square is statistically significant. It is p-value or the p-value of the f corresponding to the R square is statistically significant. I mean, it's 0.00, it's less than 0.05. Therefore, R square is statistically significant. The model fits the data very well. More specifically, about 27.3% of the total variation in the dependent variable is attributed to or is explained by the included explanatory variables, while the remaining variation is attributed to the disturbance term. This is all about question number 3. When we come to question number 2. When we come to question number 3, it states that suppose that a researcher aims to examine factors determining election outcomes in U.S. House of Representatives in 1988 for 173 two-party races. ሁለት ፓርቲዎች መካከል የተካሄደ ፉክክር ነው። ኤ እና ቢ ናቸው። The possible factors are the possible determinants are nature of the party, meaning whether the party is Democrat or non-Democrat, and we capture it using this variable, Democ A. Campaign expenditure by party A, expend A is the variable. Campaign expenditure by party B, expend B. And both variables are in $1,000. Person the vote for president. And we capture it using this variable. Share of campaign expenditure by A, share A. Here is the variable. And this variable is calculated as expenditure by A divided by expenditure by A plus expenditure by B multiplied by 100. Share of A ስንል ይሄ ማለት ነው። Then expend A እና expend B ምን አደረግን? ወደ ናቹራል ሎጋሪዝም ቀየርን። ስለዚህ len expend B ማለት ናቹራል ሎጋሪዝም ኦፍ ካምፔን ኤክስፔንዲቸር ባይ B ማለት ነው። len expend A ማለት ናቹራል ሎጋሪዝም ኦፍ ኤክስፔንዲቸር ካምፔን ኤክስፔንዲቸር ባይ B ማለት ነው። Based on this information, the researcher estimated 3 different models. ሶስት የተለያዩ ሞዴሎችን ኤስቲሜት ያደረገው ሪሰርቸሩ። የመጀመሪያው ሞዴል 1 ነው። vote A dependent variable ነው። percent of vote for A ማለት ነው። በፐርሰንት ነው ካልኩሌት ተደርጎ የተቀመጠው። Here are the variables. Democ A ማለት nature of the party, whether it is democratic or not. እዚህ ጋር the reference group is non-democrat. one if democrat ይላል። ስለዚህ ይሄ ኮኤፊሽንት የዴሞክራቱ ነው ማለት ነው። እዚህ ጋር ደግሞ percent of vote for president ይላል። እሱም አለ። expenditure by A, expenditure by B. If you look into the P values, all estimated coefficients are statistically significant even at 1% level of significance, because እዚህ ጋር እንደምታዩት statistically significant 0.05 በታች ስለሆኑ ማለት ነው። they are statistically significant. ይሄ ማለት ምን ማለት ነው? When we compare percent of vote for A, if A is Democrat, it earns 9.382% higher votes. 9.38% ብልጫ ያለው ድምጽ ያገኛል ማለት ነው። ወይ ደግሞ ነን ዲሞክራቲ የሆነው በዚህ ፐርሰንት ያንሳል ነው። እዚህ ጋር ደግሞ ለፕሬዚደንት የሚደረገው እንትን ፐርሰንቱ በጨመረ ቁጥር ኤ የሚያገኘው ፐርሰንት ቮት ይጨምራል ነው። እዚህ ጋር ደግሞ ፓርቲ ኤ ለካምፔን የሚያወጣው ወጪ $1 ሲጨምር as expenditure campaign expenditure by A, party A increases by $1, percent vote for A increases by 0.032. ይሄ ፖዚቲቭ ነው። እንግዲህ the more you spend on campaign, the more vote you are going to earn. የቢ ደግሞ ኔጌቲቭ ሆነ ስታቲስቲካሊ ሲግኒፊካንት ነው። ይሄ ማለት ቢ የኤ ተቀናቃኝ ስለሆነ እሱ ካምፔን በደንብ ሰራ ማለት ብዙ ደጋፊዎችን ብዙ ድምጽ ሊሰጡ ለኤ ሊሰጡ የሚችሉትን ሰዎች ይወስድባቸዋል ማለት ነው። ለምሳሌ as campaign expenditure by party A increases by $1, percent vote for A decreases by 0.03 on average, keeping other variables constant. ይሄንን ሞዴል ነው እንትን አረግ ነው ማለት ነው። ለምንድን ነው ይሄንን ወደ ኢንተርፕሬቴሽን የገባ ነው? because the model feeds the data very well. Why? P-value of F statistic, which is used to judge whether R square is statistically significant or not, is less than 0.05. Therefore, the model fits the data very well, and the included explanatory variables explain 62.6% of the total variation in vote A, the dependent variable. And here is adjusted R square. Adjusted R square 61.75% ነው ማለት ነው። በጣም ጥሩ። እዚህ ጋር ስታር 3 ስታር ማለት statistically significant at 1% ነው። 2 ሲሆን at 5%፣ 1 ሲሆን at 10% ነው የሚለው። ቪዲዮ የሆነ ቪዲዮ okay. So the model is useful, so you can use it for other decision making and the like. When you come to the second model is estimated using natural logarithm of campaign expenditure by party A, natural logarithm of campaign expenditure by party B. The dependent variable is the same. The only thing is these two variables are converted into their natural logarithm. The dependent variable is a level, and these two independent variables are in their natural logarithmic form. So when the dependent variable is a level and the independent variables are in natural logarithms, we need to divide the coefficient by 100. Therefore, the coefficient of natural logarithm of expenditure or campaign expenditure by party and B, which is 5.779 and minus 6.238, are going to be divided by 100. When you divide 5.779 by 100, it becomes 0.05779, and it is statistically significant, as you are observing it from the p-value, because the p-value is less than 0.05. Therefore, both variables are statistically significant, and we can interpret the coefficients. More specifically, this coefficient is the coefficient of Democ A, which captures if the party is Democrat or not, is statistically significant, and the coefficient is 3.793. And this implies that a Democrat party has a higher vote. More specifically, it earns 3.79% higher vote compared to non-Democrat party. And as we interpreted this so far, as percent vote for president increases, the percent that goes to, or the percent of votes that goes to party A also increases. Come to the campaign expenditure. We said that this is going to be divided by 100, so we get 0.05779, and this implies that as campaign expenditure by A increases by 1%. The percent vote for A increases by 0.05779% on average, keeping other variables constant. እንግዲህ ቅድም እንዳነሳ ነው እዚህ ጋር ፓርቲ ቢ ተቀናቃኝ ስለሆነ እሱ ለካምፔን የሚያወጣው ወጪ ጨመረ ማለት በደንብ ፕሮሞት አደረገ በደንብ ካምፔን ሰራ ማለት ነው እንደዛ ከሆነ የፓርቲ ቢን ብዙ ደጋፊዎችን ወደ ራሱ የማድረግ እንትኑ የሰፋ ነው የሚሆነው that's why the coefficient is negative interpret ስናደርግ ፓርቲ ቢ ካምፔን ኤክስፔንዲቸሩን $1 ነው በ1% ጨመረ ማለት የዛኛው ፐርሰንት ቮት በ0.062% ይቀንሳል ማለት ነው እዚህ ጋር r² አለን 80.1% it is statistically significant which implies that about 80.1% of the total variation in the dependent variable is explained by the explanatory variables included in the model adjusted r² እዚህ ጋር አለ ይሄ ሁለተኛ ሞዴል ነው ሪሰርቸር ውስጥ ሜታ ያደረገው ሶስተኛው ደግሞ ቅድም ኤክስፔንዲቸር የሁለቱንም አት ሌቨል አስገባን ከዛ ሁለተኛ ላይ ወደ ናቹራል ሎጋሪዝም ቀየር ነው ሶስተኛ ላይ ደግሞ ሁለቱንም አወጣንና ሼር አስገባን ሼር ማለት ቅድም እስቲሜት ስናደርግ ፓርቲ ኤ ለካምፔን ያወጣው ወጪ ለሁለቱ ድምር ከዛ እሱን በመቶ አባስተን በዚህ መልኩ አገኘን ማለት ነው እዚህ ጋር እንደምታዩት the model fits the data very well because p-value of the F statistic is less than 0.05 therefore r² is statistically significant more specifically 86.7% of the total variation in the dependent variable is explained by the included explanatory variables while the remaining 13.3% is attributed to the disturbance term እንግዲህ እዚህ ጋር እንደምናየው የፓርቲ ኤ ካምፔን ኤክስፔንዲቸር ሼር $1 ሲጨምር የሚያገኘው ቮት ፐርሰንት በ0.436 ይጨምራል ማለት ነው now from the three models which one is the best ሪሰርቸሩ የትኛው መጠቀም አለበት የሚለው ነው የተጠየቀው ማለት ነው as you may recall from our previous lessons we need to compare different models provided that the dependent variables are the same using adjusted r²የተለያዩ ሞዴሎችን r² ተጠቅመን ኮምፔር ማድረግ አንችልም ምክንያቱም r² ኢንዲፔንደንት ቫሪያብል በጨመረ ቁጥር ያ ዲፔንደንት ቫሪያብል ሲግኒፊካንት ይሁን ኢንሲግኒፊካንት ዝም ብሎ ነው እየጨመረ ኢንፍሌት እያደረገ የሚሄደው ሶ ሚስሊድ ያደርገናል ማለት ነው ኦልዌይስ የተለያዩ ሞዴሎችን ለኮምፔር ለማድረግ adjusted r² መጠቀም አለብን ስለዚህ adjusted r² ነው ኮምፔር የሚታረጉት ካልሆነ ደግሞ ኢንፎርሜሽን ክራይቴሪያ አለ እያንዳንዱ ሞዴል ላይ አካኪ ኢንፎርሜሽን ክራይቴሪያ እንደ ባየጅን ኢንፎርሜሽን ክራይቴሪያ አለን እነሱን ኮምፔር እናደርጋለን ማለት ነው ሶ ሞዴል 1 ጋር ሄደን adjusted r²ን ኮምፔር እናደርጋለን የመጀመሪያ ሞዴል ላይ 61.75 ነው ኢንፎርሜሽን ክራይቴሪያ ሁለቱም ጋር 1321 1305 አንዱ ጋር ይሄንን ከሁለተኛ ሞዴል ጋር ኮምፔር እናደርጋለን ሁለተኛ ሞዴል ጋር r² adjusted r² ወደ 79.64 ጨመረ ኢንፎርሜሽን ክራይቴሪያ ደግሞ 1300 ምናምን የነበረው 1196 አካኪ ኢንፎርሜሽን ክራይቴሪያ 1212 ባይዣን ክራይቴሪያ ቀንሷል። አድጀስትድ ስኩዌሩ ደግሞ ጨምሯል ከሁለተኛው። ሶስተኛው ስናይ አድጀስትድ ስኩዌር 86.47% አካኪ ኢንፎርሜሽን ክራይቴሪያ ደግሞ 1124 እዚህ ጋር 1137 ነው። ስለዚህ ከፍተኛ አድጀስትድ ስኩዌር ያለው ከፍተኛ አድጀስትድ ስኩዌር ያለው ሶስተኛ ሞዴል ነው ወይ ደግሞ ዝቅተኛ ኢንፎርሜሽን ክራይቴሪያ ያለው የመጨረሻ ሞዴል ሶስተኛ ሞዴል ነው ማለት ነው።